Hello, in this video we'll be learning about regular expressions. And regular expressions are a way to analyze strings, and I have a little bit of a different reading for today. It's from this book that they wrote at Berkeley, and it's chapter 8. And I'm just going to go here quick and kind of give you a bit of an introduction to the book so you can find your way around. So I'm going to head over here, and sorry, it popped up on my other monitor. And so you can see it's an online free book, has everything in this course. There's a little bit of a review here on Python strings. I think you know all that, but at least kind of go through and see what is there. And then, let me see, where am I in the book? Then this regular expression thing is the main piece. And so you can go through and you can copy these examples, and that'll all be helpful. In some of these examples, like let's say this one, when I was first reading this, I got very confused, like, well, where is this function? I couldn't run the example. And that's because for some of these cells of code, there's some hidden cells right here, so you have to expand this. And so if you want to actually run this example, I'd have to copy both this hidden cell and this here. And actually, this is a very useful function for analyzing what regular expressions are doing, and I may be using it today in the examples. So anyway, please do read that. And let me head back here. So we have that. A little bit of background. We actually have this idea of a regular language that was driven by Kleene on the right, famous professor of the mathematics department here at UW-Madison. And basically, regular languages or regular expressions are kind of like a simple pattern for matching different types of text. And you can almost think about it like we put different things in strings in Python, right? Like we put, so for example, like SQL code, SQL, or maybe there's like HTML inside of a string. In the same way, we're going to have these regular expressions be inside of strings in Python, and we're going to use them or run them to analyze other strings. And actually, it's kind of a very general thing even beyond Python. Like if I head over to this reading here, this is showing regular expressions in 10 different languages. And if you scroll down, you're going to see that, well, it's actually pretty, they're trying to hire me away. You're going to see that it's very similar across a lot of different programming languages. So it's kind of a general skill that you can learn when you're doing text analysis. Let me contrast with some things that you already know. So we've used string methods to do searching within strings before, right? I could say something like message.find 320, and if this is my string right here, then of course it'll find it, and this will be true. Do you remember what find returns? I guess I'm comparing it to an integer here, so it must return an integer. But do you remember what integer that returns? It returns the index of the starting position. So I guess in this case it would be 0, 1, 2, 3, 4, 5, 6, right? So it would return 6 because it found it at position 6. It's ignoring the later one, and that's greater than 0, so I found it. If it doesn't find it at all, then it will indicate that by returning -1. So over here on the right, I have a bunch of limitations with this find method. What if I wanted to find all the occurrences of 320 in my string? What if I wanted to find any 3-digit numbers, not necessarily these exact 3 numbers? What if I wanted to find any numbers at all? Maybe they're 2 digits, maybe they're 10 digits, who cares, right? I want to find all the numbers. What if I care about the context? What if I want to find a number before the word projects, right? Like you could imagine that maybe I want to somehow pull out something from the syllabus that's telling me how many projects we have. And then finally, we've done string replace before, but what if I want to do a more complicated pattern, right, where I want to kind of replace something that matches something specific? So regular expressions are going to be like this find method on steroids, right? We're going to be able to do all of these things, and we have to have a little language to describe these patterns. So as I was saying, we're going to be putting these regular expressions themselves in strings. It's like a little language in of itself. And so one of the things is this little language, we often use the escape character in the same way that Python uses the escape character. So maybe just a little bit of review. Do you remember what's going to print if I do this? What will show up between A and B? Well, it's going to be a tab. And so what do I do if I actually want to have a legitimate backslash and a T between here? Well, then I would have to escape my backslash, right? So I would have to do something like this, backslash, backslash. Now, because regular expressions as a language use backslashes for escaping, and Python does it too, I'd actually have to type all of this, backslash, backslash t, actually send a real backslash t to my regular expression. And so because of that, they introduced this notion in Python of the raw string, and that's just a string with the letter R before it, right? So I have these quotes, and there's an R there. 99% of the time when I see these being used, it's for a regular expression. So sometimes I think people even think the R is for regex, which is short for regular expression. But really, it's just saying that's a raw string, and it's a general feature in Python. It's saying I don't want this to be a tab. I want this to actually be literally backslash t. And so we're going to basically be doing that all the time. So I have some code here that I'm going to go over to and start working on in a notebook. I'll also share this starting code online. So let me head over here to my notebook. I'm just going to close these actually. And let's make this a little bit bigger. Like so. And basically what I've done here is I copied that function from the DS100 book that I was talking about. And we don't really have to understand it. It's kind of weird, right? But what it basically will do will help us visualize regular expressions that we're analyzing. And so then what I have is I have a bunch of strings that we're going to search for. So example, the kind of question I might ask is, what is a phone number inside of here? Or what is a URL? Or what is an email address? I guess there's no email address here, but I could ask those kinds of questions. I could try to match different kinds of phone numbers. You can see like later we're going to look at, this is a phone number, this is, I guess this one's not quite because it doesn't have enough digits. This one's not because it has letters. And so how can I write a little regular expression that captures exactly the ones I want? How can I pull out how many projects there are in the course? And lots of details like that. So what I'm going to do is I'm going to create a new cell down here. And I'm going to call this a Reg Function. And if I look at my Reg function, I'm passing in two strings. One is a string that contains the little pattern I'm trying to match. And the other one contains the text I'm looking in for that pattern. So what I could do is something like this. I could say, I want to look for, here, let me make this very clear, pattern and then text. And so maybe for my starting text, I'll start with S1, right? So I'll say I want to look at S1. And let's say I want to look for the character capital A. So I do that, and you can see that the regular expression very quickly finds all the A's, which is maybe not terribly exciting, right? I have a very simple pattern, right? So I can do that, but I can match different things. Notice it's case sensitive, like most things in Python. It's not matching those. I can match those instead. If I type something like this, A, it doesn't match anything because it's looking for these two letters in sequence. And so one of the first features that we'll use in Python is called the character class. And character classes go in brackets. And what this means is, well, I really want any of these things, right? So let me just make a note of that. So I'm going to say character class, just like that. And then I can match all of them, which is very nice of either uppercase or lowercase. We've learned all these things in Python, like brackets means like indexing your list for us before. Throw all of that out the window, right? We're learning a completely new language for matching strings. Okay, so I could do that. If I wanted to, I could do something more general. Now that I have this pattern, I could A-I-O-U. I could match all of the vowels if I wanted to, for example. So I could do that. Like so. If I wanted all the uppercase letters, I could do that too, but then it starts to be a bit of a pain, right? I mean, if I wanted all the uppercase letters, I could draw like A, B, C, D, E, F, and then maybe eventually get to Z. And so what's actually nice that we could do is we could express ranges in here. I can put a dash, and then I run that, and it's capturing all of the characters between here. So this is a character range. I'm just trying to give you all these feature names, so if you need to look them up later to do something, you can, right? So character classes, I can have a set of characters. within that, I can put a character range to capture a bunch of different things, right? Now, of course, if I wanted to actually capture these dashes, then I'd have to do some sort of escaping, right? Like if I'm looking for, let's say I'm looking for dot, I'm looking for these kinds of punctuation, right? I guess it's kind of complaining there, right? Because it can't find any of those things. What I'm going to have to do is I'm going to have to escape those, right? So it actually works. Right now I can actually find those characters within here. Otherwise it's trying to use it as that kind of meaning up here. So some of these other ones I might have to escape as well in certain contexts. Here it's figuring it out, but sometimes I might escape that. And of course, just to remember why we need this R, if I didn't have that, then, well, it's actually, I guess, working because these are okay characters. So maybe I'll come up with another example later to actually better illustrate that. Okay, so we saw character classes, we saw character ranges. Another thing I want to talk about is a negative character class. So here I was looking for all the vowels, right? And if I wanted to, I could look for all the non-vowels. And the way I do that is at the very beginning of my character class, I just put a little hat, right? So this means not. And so this will grab everything except the vowels. And notice it's also catching punctuation and that sort of thing. A very similar idea to these character classes are what we call meta characters. Really, I think of a meta character as a character that's kind of a long class in and of itself. And so we can just type this one special character and match everything. And so one example of this is /d. So if I do R, and then I say I want to look for /d, I guess I don't even need to put that in a class because it's the only thing I'm looking for. Then I can look inside of my string, and /d is for digit. So this is a meta class, and digit in this case, right? So I can do that. Other important ones you should know are /w, and so this one is white space, and so that's like tabs, spaces, new lines, all that good stuff. And actually, I'm sorry, that was that was like a word character. A word character captures all of these things. I got that a little bit wrong. So that was a word character. The white space one, which actually makes more sense, is S. So that's the white space. I could capture all of that quickly. If I want to, for a lot of these, for all of the meta characters, oh, sorry, I misspelled that up here. That's a meta character for digit. I have a word meta character, a white space meta character. For a lot of them, the capital meta character means the opposite of that. So, so this means not white space because it's capitalized. And so now you can actually see I'm grabbing all of the words separately, and I'm ignoring all of the white space in between. Another one that we might want to look at, which is very general, is just this. It is the period, and this one means match everything except new line. So I'm going to run that, and it only works if I pass in a string, of course. I'm going to do that. I guess that's capturing everything here. And because that's so general and so powerful, I'm going to have to escape it, right? So I'd have to escape it like that to actually just look for the specific periods. And then if I do this, let me run that. I guess that's still working. Still not a great example to show why we need the raw string. Okay, so I can see that is capturing all of those. I'm going to leave it off there, and we'll pick up again in the next video.